Good morning. Let's get started looking at the geometry syllabus that I've put together for us to follow. Most of the time in the order in which it's written, but we could deviate a little bit, and I might throw some things in as we're going along that might pertain to another chapter or topic, but mostly we're going to follow it in order. And let me just warn you ahead of time, you might hear a very deep dog barking. Oh gosh, that's Champ. He is a boxer and he's a bit of a puppy, not even 2 years old, but he's got a lot of energy. So he's my little COVID dog. I got him. He's wonderful. So I hope all of you are doing well during this crazy time, and I wish I could see you all, but this is the next best thing. So put in your likes and let me know how you're doing out there, and get in touch with me, email, or just send me a message because I miss you guys. First thing we got to do is realize how much paper we're going to use. We're going to use a lot of graph paper and a lot of loose leaf paper because this topic requires a great deal of writing. You're going to be learning a new shorthand language, and so in order to learn it, you have to speak it, you have to write it. And that's what we're going to do, just like you would learn any foreign language. So get yourself the paper and don't worry about how much of it you're using. Try to save it all in a binder, but definitely don't be afraid to use as much of the paper as you can. But what I'm gonna stress is that you have to use it orderly, not just jumping around on the paper from place to place like we're used to doing when we were solving our algebra problems. We have to really become orderly in the work we do, writing from top to bottom, one problem after another, and making sure that we can read our own work back to ourselves. So you're going to need some colored markers or colored pencils, regular pencils, and time to get a protractor. Your teachers will all want you to have this, a protractor that measures circles and angles, and a compass. Now, that's not the kind you take on a camping trip. That's not the north, south, east, and west measurement. That's a specific compass, and you can look up on Google what it looks like, specific to geometry. It's terrific, and you don't have to get a very expensive one on either one. You just, get what's going to work. Don't look to spend an awful lot of money. The name of this geometric study field is called Euclidean geometry, and it's all about logical thinking, drawing conclusions based on facts. So we're going to be presented with a lot of mathematical facts that were first developed by a gentleman way, way back called Euclid. He's old as the hills, and he developed this set of principles that we call the study of Euclidean geometry, logical thinking, in order for us to know how to proceed with solving problems. You're going to be doing proofs eventually, and that's when we're really going to rely on Euclid's principles of mathematics and truths that exist in the world of nature and architecture and all kinds of things. We'll get deeper into that as we go on. Euclid's geometry. We are going to rely on visual pictures and graphs a lot. As I previously stated, that's why you need all those papers in order to be functioning in this mathematical, real world set of principles. Geometry is the basis of what we study when it comes to creating things, actual buildings and artwork and roadways and airports, you name it. Everything depends on geometric principles. So I know you're going to start to appreciate where these rules and studies can be applied in the real world that you see every day. It involves the study of points, lines, planes, not airplanes. We'll get into what a plane is, angles, triangles, congruence, which means things are equal, similarity, which funny, things are similar, solids, all kinds of things, circles. And as I stated, the modern applications basic to the study of computer programming come from geometry, graphics in computers, architectural design, construction, and art. So you're going to get a good appreciation for everything related to this field of mathematics whenever you look out your window, or even in your bedroom, or your living room, or your kitchen. Everything is based on geometry. So let's get started. So now we can begin to talk about what you can expect to find and learn and be taught in this basic geometry YouTube course. The first thing we're going to study is how to write things in this new language, how to use the different vocabulary words, what they mean, what symbols to use to help express your thoughts about lines, points, planes, line segments, congruency, equality, similarity. Everything has symbols now, so you don't always have to write these long words. And you have to be able to understand them when you see them, when you're doing practice problems, when you're taking tests. You have to know what they mean. So we're going to become very, very well versed in understanding these symbols. We're also going to review and maybe even learn for the first time what we call in geometry beginning formulas. And these formulas are necessary for being able to communicate with others in the field of mathematics. For example, the quadratic formula, area formulas of different shapes, perimeter formula, slope formula, the equations of lines formula, all kinds of formulas and new ones that you haven't learned yet, but that comes later on. Now we're just really going to review the ones you've probably seen in other algebra courses and apply them now in geometry. We will also review two-dimensional figures, shapes, such as triangles, squares, rectangles, rhombus, trapezoids, kites. We're going to review pentagons, octagons, hexagons, heptagons. Some of you already know these names, and for others it'll be new. Doesn't matter. We're going to review it and get to know it really well. These are things you're going to have to memorize because it's used throughout the course. So this is a good time to get to know them. Then we can move on into the next area. Once we have finished this, we can do the next. Next, we will begin to prepare ourselves to use what we call logical progressive thinking, because you're going to need to draw conclusions with facts that are given to you, mathematical facts. And because of that fact, what can you then say must be true in order for you to proceed in solving algebraic and geometric problems? You're going to do a lot of self-talking and a lot of out-talking in class about how you plan on what I call attacking a problem. You've got to have your strategy. The only way you can get a strategy is by knowing the vocabulary, and this is the beginning of writing proofs. Okay, next is topic 3, which we'll cover after we work on proofs and constructions and logical thinking. This is where we get into a serious amount of graphing, both of parallel lines and perpendicular lines, with a particular focus on identifying angles and angle pair relationships. We're also going to be using formulas, slopes of lines, distance formula, equations of lines on and off graphs. So we're going to start getting into the old and some new formulas that you've been used to at this point. And then we finally delve into the beginning of our shapes. And now we can begin the two-dimensional shape study. The first shape we're going to study is the triangle. And that's because that's the first shape you can actually make with straight lines. It's three straight lines. It's a minimalist shape. And that means triangles are what makes up everything else in the study of geometry. So we're going to cover it a lot. We're going to learn about the triangle inside and outside and all around the town. And it is the basis of all straight-sided shapes. So for the next 5 sections, that's how important the triangle is. So let's get started. We will then proceed into the important parts of the triangle once we have the basics of a triangle under our belts. And we'll work at understanding how to prove, there comes the proofs, how to prove that two triangles are congruent to each other. So we're going to have a lot of written rules about triangles and what things occur when you have a triangle and what things don't occur. So writing proofs is really important, and in this unit we're going to study triangular congruency, which is how to prove that one triangle is equal in every way to a second triangle and maybe even a third triangle. But it's really for two triangles that we focus our attention with shortcuts. And these shortcuts are known as the 1, 2, 3, 4, 5 different congruency statements known as side, 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 angle, side, angle, angle, side, angle, or hypotenuse, leg. And we really want to use the shortcuts, the abbreviations, SSS, SAS, AAS, ASA, or HL. That's a really big part of geometry. Another is showing that triangles might not be congruent to each other, but they are similar. Similarity. And that only has 3 different ways of writing similarity statements: side, 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 angle, side, or angle, angle. This is important, really. These two are a critical part of geometry because triangles themselves are critical, and the ability to prove that two triangles are congruent to each other using the rules that you'll be taught, or that they're similar to each other using the rules that you will be taught, is a demonstration that you have logical thinking and the ability to follow steps in a logical order, almost like following recipes. So that's all geometry really is getting you used to being logical and speaking in terms that others can understand what you're saying and can follow exactly what you do, and it makes sense to everybody. The next unit continues with triangles. I told you it was going to be a while. And this unit is going to help us understand how to use special kinds of line segments inside of triangles, outside of triangles, and establishing inequalities to prove statements. Again, we're going to be proving things about triangles, but the special line segments help us understand the different centers of triangles, which are really centers of circles. And circles are everything also in geometry, triangles and circles. But when we get to the next unit, the right triangle, and that seems to be everybody's favorite. Most people automatically see a right triangle in their mind. As soon as you say the word triangle, most people picture a right triangle. But not all triangles are right triangles. There are very, very special rules that apply to right triangles only. And that's how we begin the study of trigonometry, where your calculator is going to become all important to you. You have to use it unless you plan on using a chart. Some students will be required to learn how to use a chart, a trigonometric chart, for sine, cosine, and tangent of angles. But other students, it's okay if you just use your calculator with the chart built into it. Either way, it's going to be the only way you can solve problems, either with the chart or the calculator. And this is the beautiful, beautiful right triangle. Finally, we're going to leave the study of triangles and continue to venture off into other two-dimensional shapes by adding one side at a time. And in this unit, we'll see a focus on the four-sided shape. We'll learn about 5, 6, 7, 8, 9, 10, 11, 12 rules that apply to those shapes, but it's the four-sided shape that basic geometry courses really focus in on. As we're studying four-sided shapes, the properties and rules and special definitions that we're going to learn will apply to parallelograms, rhombi, rectangles, squares, trapezoids, and kites. Those are the main figures we're going to study when it comes to four-sided shapes. It's important to learn how to transform those shapes, the ability to move them in space, because that gets us ready for architecture and drawing and computer graphics. Especially computers does a lot of transformations and formulas to transform shapes as they move across the screen. So we're going to learn all the rules that apply to moving the shapes by translating them, rotating them, reflecting them, and dilating them, along with identifying different types of symmetrical movements where things are just the same, but symmetric in that they can be folded on top of each other and hidden. So that's going to be real important also, and a lot of graphing. A lot of transformation depends on graphs. After that, the circle. As I mentioned earlier, the circle, as well as triangles and quadrilaterals, are just so important in the study of basic geometry. They have intricate parts that many of you have heard of already and know what they look like, but have done just very basic kind of work with them. This is going to get more detailed, much more detailed. The radius, the diameter, chords, tangents, secants. You're going to learn about how line segments create different angles inside and outside of circles. And we need to be able to use these. A lot of this helps us with perspective when we're drawing, computer graphics. Again, so circles, and it's getting ready for astrology. This is the field that leads you into so many other types of studies, both mathematical and scientific, and in physics. We're also going to learn about how to write equations of circles, going back to our algebra days, and conversions of degrees, which we're all used to using in circles and measuring angles in degrees, to radians, which is brand new for us, but you'll be using radians a lot more when you get into the higher level maths. So we have to at least introduce ourselves to the concept. Then we're going to have finally, the 2D, 3D comparison of shapes so that we can identify two-dimensional shapes and identify the names of three-dimensional shapes. And then we're going to find the area, lateral area, which means just the sides, and then surface area, which means every part of the shape, and volume of the different shapes that are only three-dimensional. There is no volume in 2D because they're flat. They're on paper. But three-dimensional shapes like cans of soup and other things that I'll be demonstrating, I'll show you visually what three-dimensional shapes look like. They have volume. You can put things inside them, and we'll talk about that and learn the different formulas. We'll also learn about Plato's work on solids called the Platonic solids, which, again, that word regular is going to be very important for Platonic solids. Regular polyhedrons. And density. The denseness of space, the denseness of the community that you live in. How many people can occupy the landmass area where you live. It's a very important and interesting part of geometry. And we're going to find missing measurements. You know, you'll know 2 or 3 of what you need to know, and you'll have to find the 4th thing that's missing. So there's where we manipulate geometric, algebraic formulas. And finally, we're going to cover one of my favorite all-time subjects in high school mathematics and college, and that is probability and statistics. Here's where we begin exploring permutations, combinations, variables, independent and dependent events, the normal probability bell curve, and how to find the probability using a z-table. All these are super important when it comes to studies in algebra, algebra 2, calculus, trigonometry, and especially in probability and statistics, which I highly recommend everyone take prior to leaving high school, because those of you who benefit from seeing it in high school do super well when you find it in college. You know, when you get to college, you don't do well in a course, you wind up having to repeat it, and that costs money. So I'm into everybody saving money, so let's do it in school below college, where you can get introduced to these topics and get a lot of help from your professor, from your teacher. Outside of school, you can get a lot of help. Other students can tutor you, and it's well worth it. I'm not saying it's super hard, but it's definitely super hard if you've never seen it before when you get to college. So bear that in mind. All righty, everybody, let's get started.